Hello everyone. Last video we spoke about the general structure of an atom, but we didn't talk about electrons. Well, our current understanding is that the space a single atom occupies is mostly empty. The heavy neutron-proton filled nucleus is a small part of the entire atom. The rest is like a cloud and is the space where the electrons reside. Like we said before, they orbit around the nucleus in orbitals. We will get into orbitals and quantum mechanics a little later, but the most important orbital for bonding and organic chemistry is called the valence shell, or the outermost orbital of atoms. These electrons in valence shells interact with valence electrons of other atoms to form bonds. We define bonds into two distinct categories, covalent and ionic. Ionic bonds are characterized by one atom stealing the electrons from another atom. I like to imagine the loser atom as sad and clingy, and still ends up hanging onto the atom that stole its electrons, hoping to get them back. Covalent bonds are by far the most important bond in organic chemistry. They're characterized by two atoms sharing electrons. They both get a share of electrons to fill up its outer shell. But how do we know whether a bond is ionic or covalent? Here's where the concept of electronegativity becomes important. Remember that electronegativity is the strength that the nucleus of a given element can act on the electron of another element. Electronegativity increases diagonally right and up, with the most electronegative element being fluorine. The Pauling electronegativity scale, described by Linus Pauling, gives elements arbitrary units to define its electronegativity. So, when we compare two elements in a bond, subtracting its electronegativities allows us to find out whether the bond is ionic or covalent. Ionic bonds have an electronegativity difference greater than 1.7. Covalent bonds can then be further divided into nonpolar and polar covalent bonds. If the two elements in a covalent bond have an equal or similar electronegativities, they equally or almost equally share the electrons, so the bond is nonpolar. If the two elements in a covalent bond are relatively larger in electronegativity difference, the electrons are not shared equally, so the bond is polar. Polar covalent bonds have an electronegativity difference between 1.7 and 0.4, and nonpolar covalent bonds have an electronegativity difference less than 0.4. We just reviewed the concept of valence electrons in bonding that you should already be familiar with. In the next video, we'll cover Lewis structures as well as the octet rule.